Greetings to everyone. I am Asiya Aqli, a PhD student in Kenitras National School of Applied Science in Morocco. I am happy and lucky to be a part of this conference, and I am presenting IoT Trust Management as an SIoT enabler overcoming security issues. To introduce my presentation, I will explain SIoT concepts and related security concerns. In the IoT world, everyday things interact with each other via internet, and most of these communications occur without human intervention. These interactions are the basis of social IoT, which includes also many types of relationships as for humans. These autonomous communications affect our real physical world, and this involves security concerns because everyone's privacy and safety are at stake. In fact, in such open world, devices' behavior can be dangerous if they are infected or are subject to the owner's misbehaving. However, caution should be taken wisely. A relevant example is the device we were all given as a child. Don't talk to strangers. As we grow up, we discover the importance of social networking and that nothing can be done if we don't help and interact with each other. So, to move from stranger is a danger to the great benefits of wide social network without running big risks, trust is a must. Actually, we learn how to build this trust based on experiences or on many other parameters. In the same way, objects can evaluate trustworthiness of each other. We present trust as a promising paradigm that can deal with security concerns in SIoT, while traditional security techniques are in general not applicable or inefficient in this context. Trust as a concept is an alliance joining a trustee to a truster for mutual benefit. It is a very complicated and hardly measurable degree of belief, with mitigation of the possible risk in this relationship. Trust has many characteristics. It is dynamic. A device A can trust another device B at a certain time or circumstances and entrust it on others. Trust is asymmetric. A device A may trust a device B while the device B don't trust A. Trust transitivity means that if a device A trusts a device B and the device B trusts another device C, it can influence the trust of A to C. In a certain context, a device A can trust a device B, but it may entrust it on other contexts. Also, trust is never 100%. It always includes risk mitigation. Subjectivity is an important trust characteristic. It means that a device A can trust a device B, while another device C does not trust it. Given this definition and characteristics, we can start talking about our survey, where we explore the literature related to IoT trust management. We notice that researchers name trust as an essential aspect in IoT security, even though it's a relatively new paradigm. And that trust is also a promising technique to enhance IoT security. We can conclude that trust is an aspect which deserves to be inspected in any social IoT security research. To get an idea about the interests of the scientific community in these aspects, we conduct a statistical study. We query the most important and widely used databases in this field. The keywords expression IoT or Internet of Things combined with trust management or trustworthiness gives us relevant results which we sort by year to visualize the evolution. We can see that there is a growing number of research in IoT trust management in the last years. The results in terms of enhancing IoT security are promising. Therefore, in social IoT context, trust is a paradigm which is worth to be explored. In our survey, we aim to study the interest of the trust management in dealing with social IoT security issues. Therefore, we focus on the details of the composition and the aggregation aspects in order to facilitate the choices which fit with social IoT particularities. Building trust management evaluation is based on adjusting multiple parameters and combining them via an aggregation method. The definition of relevant metrics is a key step in trust evaluation. We can choose into many metrics, which are classified into two categories. QoS-based metrics that evaluate the capability to provide the service and qualifies the performance via several metrics as packet delivery ratio, success rates, energy consumption, and task completion capability. The second category is social metrics that are based on devices' social relationship. We name honesty, cooperativeness, community of interest, recommendation, reputation, centrality, knowledge, and owner's relationship. To assess an aggregated trust value, we need to combine many metrics. Many techniques are used in the literature, as weighted mean, regression, Bayesian inference, fuzzy logic, particle swarm, and machine learning based methods. In this table, we summarize the implementation of the cited aggregation methods in the literature. Given this, we can infer trust system challenges. Every system that aims to guarantee an appropriate level of trust and security in social IoT communications must respect some constraints related to IoT characteristics. It has to be a lightweight solution with minimal resource consumption. Take in account different hardware specifications and standards, and deal with mobility and multiple interactions and protocols. The metrics used for trust composition need to be generic, easy, and legitimate for collection. These characteristics are more available in QoS properties, which explains why this type is the most used in literature. However, for an efficient trust assessment in social IoT, social properties are essential parameters to consider, although their collection and calculation are harder. To choose a management method, we need a trade-off between performance, which can be measured via numerous parameters, and constraints related to IoT characteristics. The choice of trust category is also challenging. We often tend to decide on trustworthiness in a deterministic way to avoid unsatisfactory experiences, as a policy-based model or certificate system. However, in the IoT context, which changes frequently and unpredictably, we can hardly implement a totally deterministic solutions. We need non-deterministic methods as recommendation-based, reputation-based, prediction-based, or social-based systems. Thus, without non-deterministic trust management methods, devices will not be able to provide a service or complete a task. Trust management system must be aware of any attacks that can corrupt the results. As it is an interactive procedure in IoT context, trust management is vulnerable to many types of these attacks. We have self-promoting attack, bad-mouthing attack, whitewashing attack, opportunistic service attack, collusion attack, cyber attack, or on-off attack. An efficient solution should be insensitive to these trust-related attacks. So, we conclude this presentation where we highlighted the trust management importance for IoT security and the rising focus of scientific research on this field. We deduced that trust management is a promising way to trade off between security challenges and the open, ambitious prospects in the social IoT world. In order to help choosing the most important parameters for any future system design, we surveyed trust specifications and we described the most popular trust calculation methods and metrics. And finally, we pointed out issues and challenges which should be considered for development of an effective trust management system in social IoT context. Thank you for your attention, and I will be glad to answer your questions.